MS Ramaya University of Applied Sciences.
Hello students, in this video we'll be initially discussing the theory on manufacturing process, lathe and its accessories, and subsequently dealing with different types of operations performed on lathe machine. Manufacturing process. The process of converting raw materials, components or parts into finished goods that meet a customer's expectations or specifications. Manufacturing commonly employs a man-machine setup with a division of labor in a large-scale production process in which a sequence of operations are performed on the rock workpieces so as to convert it into desired product. Classification of manufacturing process. Different types of process performed in manufacturing industries, namely process type manufacturing. It involves continuous flow of materials through a series of processing steps to obtain finished product like oil and chemicals, textiles and etc. Fabrication type manufacturing. It involves manufacturing of individual parts or components by series of operations such as machining, forming, and welding. Assembly type manufacturing. The parts or components are put together to get a complete product such as machines, automobiles, aircrafts, and etc. Machine shop practice. Machine shop is a place where students acquire the knowledge on the machining operations involved in production of various components. The production consists of cutting, milling, shaping, drilling, finishing, and other processes that can be performed on machine tools typically include lathe, milling machine, drilling machine, and grinding machine. Machine shop practice. Machine shop practice is important because it gives hands-on experience on the use of different types of machine tools, cutting tools, and sequence of operations that can be performed on the various engineering components. Machine shop practice. The purpose of machine shop practice is to enable the student to know the workers involved for an processing of components, machinery or equipment, time required for finishing the job and estimate the production cost. Machining applications. Machining is a manufacturing process by which parts can be produced to the desired dimensions and surface finish from a blank by gradual removal of excess material in the form of chips with the help of a sharp cutting tool. Manufacturing industries for making the various types of jobs for automobiles, machine tools, aircrafts, energy generation sectors, and medical devices. Pulleys, shafts, bushes, gears, cylinders, camshaft, engine block, and many other automobile parts. Machine tool parts, press tools, tool and die making applications, aircraft, spacecraft, industrial, surgical, and orthopedic components. Tools used. A tool is a device used to remove the material from any workpiece. Hand tools and machine tools. Tools which are used manually by human effort. Hacksaw, files, fitting tools, machine tools. Machine tools are the kind of machines on which metal cutting or metal forming process are carried out. The machine tools employ cutting tools to remove excess material from the given workpiece. Some of the machine tool examples: lathe machine, milling machine, drilling machine. Material removal or machining process. The machining process involves removal of extra material from a given workpiece to get it into desired shape and dimensions with better surface finish. Metal cutting. Single point cutting tool is used in turning, shaping, planing and boring operations. Multi-point cutting tool used in milling, drilling, tapping, broaching operations. Grinding and finishing. Surface grinding, cylindrical grinding and centerless grinding. Lapping, honing, super finishing. Unconventional machining, ultrasonic machining, electric discharge machining, abrasive jet machining, laser beam machining, and etc. Selection of suitable process. Following factors influence the selection of suitable process, namely workpiece material, shape and size of workpiece, degree of dimensional accuracy, surface finish required, number of products to be produced, and cost consideration. Introduction to lathe machine. The lathe machine is one of the oldest and most important machine tools. It is also called as mother of machine. As early as 1569, wood lathes were used in France. The lathe machine was adapted to metal cutting in England during Industrial Revolution. A lathe machine is a machine tool which is used to remove metals from a workpiece to give a desired shape and size. It is a machine that is used to perform various metal removing operations such as turning, grooving, chamfering, knurling, facing, forming, and etc. with the help of cutting tools. Working principle of lathe: removing excess material by forcing cutting tool against the rotating workpiece. Movement of cutting tool: parallel to axis of rotation of workpiece, cylindrical surface; perpendicular to axis of rotation of workpiece, flat surface; inclined to the axis of rotation of workpiece, conical surface. Types of lathe: the various types of lathe machines commonly used are center lathe or engine lathe, speed lathe, bench lathe, tool room lathe, turret lathe, and capstone lathe, CNC lathe or CNC turning center. Center lathe or engine lathe. Engine lathes are the common types of lathe machines used in machine shop, and it is also called engine lathe because the first type of lathe was driven by steam engine. The power to the engine lathe spindle may be given with the help of a belt drive from an overhead line shaft, but most modern machines have a captive motor with either a cone pulley driven or geared headstock arrangement. The machine can operate at a wide range of speeds and feed rates. Various metals can be machined. Speed lathe. It is very simple in design. It only has headstock, tailstock, and very simple tool post. It can operate in 3 to 4 speeds. The spindle speed is very high. It is used for light machine works like woodcut turning, metal spinning, and metal polishing. Bench lathe. A bench top model, usually a low power, used to make precision machine small work pieces. It is used for small workpiece having a maximum swing of 250 mm at the face plate. Practically, it consists of all parts of engine lathe or speed lathe. Tool room lathe. Tool room lathe is very versatile lathe machine. It can give better accuracy and finishing. It has wider range of speeds and feed rates. This lathe is mainly used for precision work on tools, dies, gauges, and in machining work where accuracy is needed. Capstan lathe. Capstan lathe is a lathe designed to use a number of cutting tools mounted in a rotating turret or capstan and arranged to perform turning operations. The main difference between capstan and turret lathe is that on a capstan lathe, the turret's saddle is clamped to the bed. Turret lathe. Manual operation is replaced by a turret that holds multiple tools. Tools are rapidly brought into action by indexing the turret. Tool post is replaced by multi-sided turret to index multiple tools. Turret lathe is larger than capstan lathe. Applications: high production work that requires a sequence of operations on the part. Computer numerical controlled lathes or CNC lathes. Computer numerical controlled lathes are rapidly replacing the older production lathes due to their ease of setting, operation, repeatability, and accuracy. They are designed to use modern carbide tooling and fully use modern processes. The part may be designed and tool paths programmed by CAD or CAM process or manually by the programmer. Parts of center lathe. The major parts of center lathe are bed, guideways, legs, chip tray, headstock, spindle and chuck, tailstock, carriage, apron, saddle, cross slide, compound rest and tool post, feed mechanism, feed rod and lead screw. Lathe bed. The bed is heavy, rugged casting in which are mounted the working parts of the lathe. It carries the headstock and tailstock for supporting the workpiece and provides the base for the movement of carriage assembly which carries the tool. It has better compressive strength and excellent shock absorbing capacity. Guideways. Generally, the combination of both flat and inverted V guideways is used in lathe bed. Legs. The legs carry the entire load of machine and are firmly secured to floor by foundation bolts. Headstock. Headstock is clamped on the left of the bed. Main function is power transmission. Headstock spindle. Hollow cylindrical shaft supported by bearings provides rotational motion to the work holding devices. Live center or chuck. Live center or chuck is fitted to the spindle nose to hold the workpiece, driven by stepped pulley or transmission gears. Tailstock. Tailstock is movable casting located opposite the headstock on the base of the bed. Tailstock can slide along the bed to accommodate different lengths of workpiece between the centers. Tailstock clamp is provided to lock the tailstock at any desired position. The tailstock spindle has internal taper to hold the dead center and the tapered shank. Tools such as reamers, drills, and drill struck. Tailstock applications. It is used to support long workpiece while machining. It also used for holding the drill chuck and feeding the tools like drills, reamers, taps, and etc. Turn the tailstock hand wheel to advance the ram to hold the revolving center and support for right hand and work. Carriage. The carriage is located between the headstock and tailstock and serves the purpose of supporting, guiding, and feeding the tool against the job during operation. Carriage is used to move cutting tool along the lathe bed. The main parts of carriage are apron, saddle, cross slide, compound rest, and tool post. Carriage assembly. The carriage has the following five main parts. Saddle. It is a head-shaped casting mounted on the top of the outer base, provides support for cross slide and apron. Cross slide. It carries the compound rest and tool post. Can be moved by power or by hand. Compound rest. It is used during taper turning to set the tool for angular cuts. Tool post. It holds the tool firmly in a proper cutting position. Apron. It is attached to the saddle and hangs in front of the bed. It has hoses, gears, levers, and clutches for moving the carriage with lead screw for thread cutting. Cross slide. Cross slide is mounted on the top of the cross slide. It is used to support cutting tool. It can be swiveled, rotated to make angular or tapered cutting. Its regular base, its circular base called collar is marked with degrees and that ensures accurate swivel setting. Cutting tools. It depends upon the nature of operations done, namely plane turning, potting tool, threading tool, boring tool, and knurling tool. Lathe accessories. The accessories are employed for handling and supporting the work and tool on lathe. The following attachments are commonly used. Work and tool holding devices are chucks, lathe centers, face plates, drive plates, lathe carriers, or docks, rests. Chuck, work holding device. Chuck is used to hold or grip an object with radial symmetry, especially a cylinder. Three-jaw chuck, self-centering chuck, used to gripping circular or hexagonal cross sections. Four-jaw chuck, independent jaw chuck, used to gripping non-circular cross sections. Drill chuck, it is tool holding chuck. A drill chuck is a specialized self-centering three-jaw chuck and usually hold to drill bits of size 2, 12 mm diameters or other rotary tools. Lathe centers. A center is used to support longer work pieces where the cutting forces would deflect the work excessively, reducing the finish and accuracy of the workpiece or creating a hazardous situation. Dead center. It is used to support the workpiece at either the fixed or rotating end of the machine. Live or revolving center. It is constructed so that the 60-degree center runs in its own bearings and is used at tailstock. It allows higher turning speeds without the need for separate lubrication and also greater clamping pressures. Lathe carriers and docks. A lathe dog, also known as a lathe carrier, is a device that clamps around the workpiece and allows the rotary motion of the machine spindle to be transmitted to the workpiece. Steady and follow rests. The steady rest consists of a frame and three adjustable jars which support the work. The main purpose of the steady rest is to prevent springing or deflection of slender, flexible work. Another purpose is to furnish auxiliary support for the work to permit heavy cuts to be made. A third is to support work for drilling, boring, or internal threading. Machining parameters. Selection of machining parameters during turning. Cutting speed V. It is a relative surface speed between the tool and the job. It is a primary motion and peripheral speed. The formula is as shown. Feed rate F. It is relatively small movement per cycle of the cutting tool. It is a secondary motion. Formula is as shown. Turning operations, feed rate in mm per revolution, and milling operations, feed rate in mm per tooth. Machining parameters. Depth of cut D. It is the perpendicular distance measured from the machined surface to uncut surface of the workpiece. It is a single parameter. D is given by d0 minus df divided by 2 in mm, where d0 is initial diameter of the job and d suffix f is final diameter of the job. Material removal rate MRR. It is the volume of material removed per minute. MMR is given by V into F into D mm cube per minute, where V is equal to cutting speed, F is feed rate, and D is depth of cut. Machining time T suffix m. It is the time when a machine is actually processing. T suffix m is equal to L by Fn in minutes, where L is equal to length of cut in mm, F is feed per revolution in mm per revolution, and N is spindle speed in RPM.
At MSR UAS, we spark your imagination unlike any other.